Thank you everyone for joining us today. And today we are talking about Cartographer. Cartographer allow you to create secure and reusable supply chain that define all of your application CI/CD in one place in cluster. And it's been a new project and it's recently joined the CNCF community, CNCF landscape. And today I am joined by Vashuma Wanjohi. Really sorry if I'm pronouncing your name incorrectly. Thank you very much, Vashuma, for joining me today. Just introduce yourself to my audience.
Yeah, hi, you nailed it. My name is Washuma. I am a maintainer on the Cartographer project. As you mentioned, we're an open source project all about coordinating Kubernetes resources to deliver code to production. Um, I have been a software engineer for a couple of years now. I've always been working on the uh, I've always been working to serve developers who are trying to get code out there, working to serve those DevOps folks who are like, okay, yes, I understand. Like, I need to. I am going to write code. It's going to serve my customers, and I'm going to be part of that loop that like keeps that code running and good. Um, that's a lot. So I've always been excited to be part of a team building products to make that part of developers' jobs easier.
Yes, absolutely, absolutely. And according to the book that I recently read by the book Continuous Delivery book by Jazz Hamble and David Foley, I think they're written 11 years ago. The most important problem that we face as software professional is this: if somebody think of a good idea, how do we deliver it to users as quickly as possible? And according to the cloud nativity definition by Joe Beda, the co-founder of Kubernetes project, basically addressed the same problem. The cloud native is a structuring team, culture, technology to utilize automation and architectures to manage complexity and unlock velocity. And as of today, we do this every day before moving to our code to prod. We do these steps every day, and each of these new steps that we generate does give rise to a new tool, and we have tool to automate each of these steps, and every new tool we generate a new sort of learning curve. Like the typically DevOps pipeline has looked to watch for a repo, scan source code, build images, do some testing, some workload configuration and deployment. And these individual tools need to be somehow connected between them and wired between them using this sequential pattern where each step is completed sequentially in a linear manner. And also, in order to manage the flow of automation between the steps, we rely on entity that is that follow the orchestration pattern. And is it something like the server client pattern that we already know? But this orchestrator job is not only to know what should be done, but it should take how the step in supply chain needs to be done. So today's our talk is focusing about, as we learned recently, that the cartographer is a built on this choreography pattern that we dive into today. So before we talking about some of the wonderful cool stuff that we have with that we have with the cartographer, tell us about Vishuma that what is choreography? We always talking about orchestration thanks to the Kubernetes, but when I recently heard about the choreography, so tell me, my viewers, about it. What is choreography pattern, and how you implement this pattern in a cartographer?
Yeah. So when when you go and see when you go and you want to read up like what is orchestration versus choreography, the places where you'll find that discussion most is not in uh, continuous delivery, the space that we're in, but actually in the architecture of just applications. Uh, and that's great because we're all already familiar with that choreography pattern, it's the microservice pattern. Uh, it is the idea that uh, if you take a program and you start writing it, at the beginning, you're going to be orchestrating. You're just going to say, "Hey, I've got this mono repo. I'm going to have everything that happens in my application happen synchronously, and that'll be like quick for me to easy for me to reason about and quick to develop." And that works until you need to get to scale, um, both in terms of, hey, I've got a lot of users. I'm starting to have to like scale this out horizontally, um, as well as, hey, I've got a lot of developers, and my developers are suddenly getting stuck uh, making changes to this one big application. I want to decouple the work of team A from team B so that both of them can run really fast. Um, and what then all that needs to be managed is that API, that communication between those different microservices. Uh, and that there we have the choreographer. The entity that we think of as the choreographer is that entity that is collecting messages from microservice A to provide it to microservice B, C, D through N. Uh, so then when we think about Cartographer, how is this working in the continuous delivery space? Well, we just say like, hey, as you have already pointed out, there are a lot of known steps that have to happen uh, that we already conceptually bundle in our heads, but in our code, it can often just be that mono repo, uh, that definition of a bash script from A all the way through Z. Uh, with the choreography pattern, you can say, hey, let's isolate, let's break out step one, allow it to spin on its own, and when it's done, it will send a message up to a choreographer. My favorite one is Cartographer, uh, and uh, and then that choreographer is responsible for passing that message on to the next entity to make that available to any other steps in your path to production that require.
Yes, absolutely, absolutely. And also, I think before we start just conversation around the choreography and the orchestration, I think that right now the major pain point today's we people face is a tight coupling between these tooling. Like when you build out, like you have to watch a repo. You need a tool. That is, you have a GitHub repository. You need a Git tool to watch a repo. Then you have to scan the images. You need another tool for that. That is might be Trivi or Tracy or might be some other tools in the. And then we have to build out some images. And using these building images, you have plethora of tools available. And also you have to test. Then we have a workload configuration. Then we have a deployment pipeline. There is a plenty of tool available in every step of execution. And do we have kind of a flexibility that we wrap up these steps in a let's say in a power generator, or let's say in a powerful machine that can encapsulate each of these steps, and you just give them an input and it's give you the output. And by swapping technology is really easy unless it's generating the same output. Like I tend to see like a cartographer is using the same analogy as we do in the eventing. You give them some input, it give you some output of that. And unless these output are generated by the different tools and technology, the swapping is not any problem for everyone. So that is a major benefit to that. And also I think the may to the conversation. So as far as I know, as we implement like cartograph for everybody listening to us right now is implemented by a choreography pattern. And Vishuma explained wonderfully well that how orchestration is different from the choreography. And tell us about some under details, Vishuma, on how it's work under the hood. What are the different resources available for me? How how is it working with the Kubernetes as of today? What are the different platforms it's work under the right now, and how its different pieces work together to solve a biggest problem, to remove tight coupling and inconsistent path to production. You are muted, Vishuma.
Thank
You
you.
are.
I, one question that you asked was, does this work with Kubernetes? Yes, we are Kubernetes native, and in fact, I would say that the most important thing to, or when I think about Cartographer, uh, part of the advantage to me is that uh, you know writing code. I want to run my code in Kubernetes. I often want to more and more where we are delivering our code as Kubernetes custom resources. Uh, and what we see is that a number of these tools that you're talking about are moving that direction. So, for example, we have Pack, which is an implementation of cloud native build packs, uh, and we see that there's a Pack CLI. It's great. Uh, Even better is Kpack, which is the Kubernetes resource that allows you to do that. And when you say, "Hey, I want to utilize all those Kubernetes custom resources, and I want to string them together," that's where Cartographer is that tool that's going to allow you to do that. Um, so you said, what are the different tools that or what are the different resources that are used for building building a supply chain out of uh, in Cartographer? And I'm going to share my screen. Give me just a moment. And I'm just going to do a little. Yep. Oh goodness. It's asking me to share. Yes, share.
Yes, absolutely. So while Vishuma is sharing the screen, everyone who is listening to us or watching us today, do share your question related to the cartographer or geography pattern. And if you're completely new, feel free to throw those in the chat. I will be continuously monitor the chat and will ask those questions live with Vishuma. So if so, just a question around as you're sharing the screen during the point. Just basically, what are the different resources available under the hood in the cartographer? I see the cluster template, the supply chain, cluster supply chain template. So just tell my viewers how these different components work under the hood. And if you have difficulty sharing your screen, let me know. You can share the link with me so I can do my sharing.
Uh, yeah, so uh, first, my apologies. It's telling me Google Chrome will not be able to record the contents of your screen until it quits. So I'm going to disappear for half a second to quit and reopen. I,
Okay.
StreamYard.
Okay.
Give me just a moment. I will be right back.
Yes, absolutely, absolutely. We all waiting for you. We all waiting for you. So, as Vishima join us again, just feel free to share those questions in the chat. I will continue to monitor the chat, and feel free to go to the cartographer.sh, where you see all the details in the cartographer, how it's work under the hood. It's a bit wonderful details available. I see some of the demos that I run today is well documented, and it's been a ton of very good documentation available if you want to try those in. So while the Vishuma join in, so I just give you the story of cartographer in a brief summary of what I have learned so far. So, as the card, we know we have different sequential steps in the supply chain. We have a source repo that we watch for it. We have scan code, we have build imaging, we have testing, workload configuration, and deployment. And every of these tool steps have different tools available. So like to watch a repo, you have a Git code. For the scan a source code, you need a Trivi, Tracy, or different tools. For build the image, you have Kpack, Docker, Kani code, different tools. For the testing, you have different tools. For workload configuration, you have tons of different tools. So now, so yes. So now, uh, so Vishima join us again. So
Yeah, let's
now
try
you
this
resume
again.
that part. Yes, I can see the
All
screen,
right,
and
changes.
hopefully everyone able to see your screen.
Excellent. Let me change this so that I'm sharing not that window. Okay. Okay, you can see my screen now?
Yes,
Continue our
absolutely,
board? Yes.
absolutely.
All right. Okay, so at the heart of Cartographer, we have supply chains. A supply chain is a place where you're going to define your path to production. What are all the steps that need to take place in order to get to build your application? There are two other entities that are very important to understand uh, in that conversation. One is the workload, and another is templates. Uh, Essentially, all information that you'll need in order to uh, in order to go through the steps to that testing, that scanning, that building that you've described will be encoded in between these three objects. So what's the relationship between them? As I said, the supply chain is this overarching object. Uh, in the supply chain, we're going to define a number of steps. And in the actual resource, they're referred to as resources. It's a bit of an overloaded term. So in discussing it, I always call them just steps. But we'll see later in the YAML um, uh, what those are. And the each step will have a one-to-one relationship to some template. Uh, the the supply chain is going to be responsible for providing information to the template, and some of that information will come from uh, workloads. Uh, that is going to be information that's specific to the application developer. So the most canonical thing that we would think of is where is the code? The developer has written some code, they've pushed it up to Git somewhere, and they need to, in a workload, just say like, hey, this is the location of that code. And the supply chain will then be able to say like, oh, okay, I can provide that code location to a, the first step to the template. Uh, Given that, uh, some information from the developer, and then some template of a Kubernetes object that the app operator has created, uh, a new object, Kubernetes object, will be stamped out. This would be, for example, I mentioned Kpack, so we might stamp out a Kpack image, and that is uh, a a resource, an object from a tool that knows how to do some part of our path to production. So this object is the result of our template. That object is going to, once it's submitted to the cluster, there's going to be some controller, some operator on the cluster that knows how that object works. And it'll say, hey, I've got this, this object has some spec. I'm going to spin, I'm going to do some work. And then in that Kubernetes way, it will amend the object and place a status on the object. That status will report back some information. Like, for example, hey, I made an image. Here's the location of it. It's in this registry over here. The template then knows how to read the object, the status of the object, and it's looking for that particular piece of information that's been submitted. And once the template has that information, it provides it to the supply chain again. And the supply chain is then able to share that information. One, it it will update the workload so that the workload is able to reflect to the end user values that they care about. But even more, it's going to be able to do this entire dance, you might say, for Choreographer, with a second object, a second template and object. Uh, and that's how Cartographer is simplifying the work uh, that needs to happen. As you were describing, it can be KPAC is this resource that's being developed without thinking about, hey, is there some API that I need to maintain between myself and a Kubernetes native image scanning tool, for example. And rather than sitting about and waiting and saying like, oh, I wish these tools communicated with each other in a more natural way. Instead, we can just simply say, hey, the world is as it is, and we've got these powerful tools. Let's use them today. And so by wrapping them in these templates and then referring the templates to the supply chain, we're able to move information between these powerful tools that don't necessarily share an API. Cartographer wraps them in a simple API.
Yes, absolutely, absolutely. Wonderful explanation. Its diagram is giving us a wonderful insight. What are the different resources available? So, in a supply chain, when you submit a workload, when you submit a YAML or workload configuration to the supply chain, it's underlook the template that are available as of today in the cartographer. These might be the template for the image building, might be these are templates for the image deployment, and might be these are the template for the configuration config template. And
Mhm.
these template, it's give you some output, and then the output is giving is providing the next step. Like first time, let's say we have a flux tool that is available of today. It's watch for the changes that are available in the, it's detect the new commits in the GitHub repository. And once these URL is available, we can build the new images by using the, let's say, the KPAC. And when the new image is available, we deploy the to the K. Let's say the third step is to deploy using the Knative service. So that is a third service. So every step is providing some input and output, and might be some steps don't haven't provide any output. So these are the template, those resources that do not provide any input. So those are providing output. There are some 5 or 6 template. And also tell us about the another resource that's available, cluster supply chain. What it does actually, what the whole cluster supply chain. As of I know, I think it's wrap up each of these steps inside over it, and on side of these steps, uh, you by just using, we have a dev flow and we have an ops flow. Might be you tell the dev team you can change the tool that you are using for, let's say, testing or staging, testing the images, but you can't change the tool that you're using for the scanning the repos that are standard for it. So that is flexibility is available. That's the biggest advantages of using the cartographer today, because you find those suppression of concern in a DevOps pipeline that is not very hard to maintain if you do it manually. So tell us about, my viewer, about this suppression of concern point of view in the cartographer.
Yeah. So, I started off saying that I got into the thing that I really love about this field is that we're making devs' lives easier. And part of that is protecting them from a lot of the complication that is going on here. So one thing that I didn't really demo here, on a just make sure it's really clear. We've got, you said separation of concerns, and we've got that. Uh, these objects, so these are two cartographer objects, and these are objects that are the concern of what we'd call the operator persona. This is the person who is specialized in knowing how do I get, what steps in my organization does code need to go through, uh, and that's the sort of thing that can be standardized over lots of different apps. Uh, and so we call this, we'll label this with app operator. Uh, and then we've got this other set of objects, these workloads. And the workloads are uh, the concern of app devs. The app devs are doing all sorts of different things. They may be focusing on, they're focusing on customers. They're focusing on how do I create a ticketing system, and how do I create an inventory system, and how do I create a marketing system. All the things that are really driving the value for whatever your company, whatever your organization is doing. And so they don't each need to know about how code gets built. They need to write code that has their business logic in it. And so the really nice thing about Cartographer is that team A comes in and they'll submit a workload that matches with a supply chain, and that workload supply chain pair will stamp out an object. Each template will stamp out its own object. And then we can get another app dev team that has another application, and they submit one workload to the cluster, and suddenly we've got another logical supply chain, another set of objects that are being built out. So you can imagine, well, this scales really wonderfully. If you have 10 app dev teams, they're all able to focus on just, hey, I wrote my code, I provided some simple information in the form of workload to the cluster, and then all the rest of those steps just happened automatically. You and I want to pause right here because you had asked a specific question, and I feel like I haven't addressed it, and I wanted to ask you, can you restate the question? Because I think I've gone off on a tangent.
Absolutely, absolutely. I think you address this wonderfully. Like, I just explaining the question here is like it's giving some input and output, and these of output is giving to the another field, and it's just generate the output. So just the question is my like, what is the supply chain does in the cartographer? And as of I learned, like you give it's wrap the whole execution like in a cluster supply chain. These are step related to wash the repo, scan the GitHub repository, you can build the images, you have perform some testing, you perform some workload configuration, and then you do the deployment. You wrap all those stuff in a cluster supply chain, and the biggest advantage of that is but you just scale out these different objects. You can scale out not just one application but different application. You just tune the knobs of the different configuration, and it's just supply automatically. And we also learned about the template, different templates available. And as if I learned, like when I run my experiment today, like one of the thing I really like about it, when you have, let's say, there are three steps. You have a flux, GitHub, git changes repository, the GitHub sync, and then the next step is to build the images. That is might be the Kpack or Builder or Conico, and might the third step is to deploy my application to somewhere. And let's say I'm using the Knative service. If I do this manually, I have three YAML file for each of these steps. But in a cartographer, you wrap this up in a whole cluster template, and template you give them an output, and then these become the input to the next step, and then the next step is become the output of the sequential process. So and you can make that generic. You can even swap out different application by using that. And You can give the configuration management on the fly run and on this stuff on this point of view. So so that is the beauty of, let's say, the is a choreography pattern. But people who really joined us, let's say, today and is really new to, because I'm really new to the choreography pattern. So how, tell us the people, why should we go from orchestration to choreography? Because that is becoming the natural question in the people mind. But I see the orchestration layer is sitting on top of it, and if something happened to them in orchestration layer, or in the master play goes down, there is a huge chaos underneath it, because there's no orchestrator over there that can manage the failure of the node, who can detect what is going to be happen. But I see that if something happened to the choreography pattern or the choreographer, things are not as chaos as an orchestration pattern, as of I understand it. So tell my viewers about the this notion of single point of failure, as we're talking about in the orchestration and versus the choreography.
Yeah. So uh, again, the analogy when we think about microservices, those the advantages that you get with microservices apply here to choreography uh, in continuous delivery. So uh, part of it is that each of these tools will run independently. If I define a KPAC image to build images, and then I define another Kubernetes resource that's going to scan those images, uh, those are two essentially independent programs, right? They're two resources, two separate controllers that are running on a cluster, and if one of them goes down, well, that's bad, right? Like new code that comes into the pipeline isn't going to be able to, if step uh, three is not doing work, step four isn't going to be able to do new work that enters the pipeline after the point of failure, because it has to get through step three. But anything that step three has already processed, uh, step four is independently able to spin on it, is it able to do work on it. And so that's a big advantage. Uh, the the other advantage is that by moving to this choreography pattern, you can also start to separate out who needs to be an expert in each piece. Uh, one of the I remember I've talked to some folks about CI/CD, and I've heard folks say like, "Oh, I'm at the beginning of my journey. It just feels like I've got a ton of Bash scripts," um, and that's that's one of those smells of the orchestrator pattern. Is you're defining you never get you can never pop your head up to another layer of abstraction. Uh, it's always bash all the way down. You're always like coming back and saying, okay, I defined this step, and I've got all this imperative code that tells me how that step works. And if something goes wrong, I'm going to have to go in and I'm going to have to tweak that. Well, if instead you are using a declarative Kubernetes resource, you are essentially offloading to somebody else the that expertise. And so when you move from, hey, I want to build images with a Docker file, it's super imperative, and use tools that, I mean, don't get me wrong, Canico, it's great, and you can use it in Cartographer. Uh, but what we're really trying to empower you to do is to say, hey, I'm going to move to tools uh, that isolate that expertise in the tool itself, uh, and minimize the amount of configuration that I need to provide, make it declarative in the way that I provide that, and in so doing, uh, allow everybody to specialize on to specialize. Just put it that way.
Yes, absolutely, absolutely. And I see like one of the wonderful repository that I'm searching on the internet, like there are some example repositories available. If you want to try those out, I will definitely share the link in here. I will try to find out all this. So, Bashima, do you have some quick demos that you can show to my audience prepared? You are absolutely go to it, because that's is going to be awesome when we see some of the demos that you wrote up.
Yes. Give me just a moment so I can switch to.
So I see some of the friend in the chat. Javid, how are you? Thanks for joining us today. And Bhutan is one of a friend of mine from Turkey. Thank you for joining. And now it's Jammer time. Is you just hit the bump up for your font size of your screen. Otherwise,
Oh
look
yeah.
it's look great.
Let's go to. Uh, oh, there we go. Okay, I might have to switch back and forth because I always forget how to get my project window open in this mode. But yeah, here we see the actual YAML for defining a cluster supply chain. You asked before, I've been saying supply chain, you've been saying cluster supply chain. The actual resource is actually cluster supply chain, and that is in reference to the templates and the supply chains are cluster wide. The app developers, the app operators define that for all workspaces, and then app devs can be in their own namespace. It can be isolated in namespaces. Workloads are namespaced, whereas the supply chain, the templates are not. So here we have a basic supply chain. It's really basic because we see the steps, the resources are, we've only got one. There are two pieces of information that we provide here for each resource. We have to give it a name. This is how the supply chain is going to refer to this resource. And then also we say, okay, which template is this pointing to? And so here we see there's some cluster template that is named app deploy. In addition, our supply chain, or cartographer, I should say, the cartographer controller is meant to be able to stamp out resources in the cluster. It generates new Kubernetes objects. And that's really powerful. It many people refer to cartographer now as a controller of controllers, because you define some resources at the cartographer level, and then suddenly, and it's a controller handling those, but then they lead to other controllers spinning up and doing work as well. That's really powerful, but also, hey, that's a lot. That's you could stamp out anything, and so you always need to provide some service account to the cartographer controller saying what objects is the controller supposed to be able to stamp out. So that's your standard RBAC. And then you provide some selector. And this is what labels do you expect to find on the workload, so that we know, hey, this workload that has been submitted, it belongs to this cluster supply chain A, rather than cluster supply chain, some other cluster supply chain B. So that is the. There we go. So that's our supply chain. Next, we would want to see, I mentioned that there was one step. It's an app deploy step. What's in there? Well, that is, it is an object that has one super important field, a template. In that template, we'll have lots of fields that we are able to just hard code out. We'll say every workload that's submitted will always follow this pattern. We can see in my app platform, when somebody submits a workload, it's going to create a deployment. and it's always going to have 3 replicas. But there are other fields that I don't know that are going to be important for saying these fields will be specified based on the values that the workload brings. Uh, Sometimes those are just things like names. So when we're stamping out namespace objects, that's really easy. We can just say, hey, take the workload's name and make that the name of this object, since we know that in that namespace there won't be two workloads with the same name. Now, in this there in this namespace, there also won't be 2 deployments with the same name. Others will be values that I go back to only the app dev would know. So here in my very simple supply chain, uh, the scenario that this aligns with is, let's say we're just saying, hey, I expect all of my app devs to have already built an image, and they've pushed it up to a registry, and I want them to submit a workload that just tells me the location of that. And then I'm going to apply that to the cluster. I'm going to create a deployment that runs those images. And we can see here that the workload, we will be able to pick up that value from the workload. Let's look then at workload example. Here we see this is the only file that an app dev needs to supply. And we can see like, wow, it's under 10 lines of YAML. And that value that we were talking about, the spec.image, they write it in. And when they submit, all of those deployments will be created. Similarly, we can see some other app dev can come in and say, hey, I'd like to build a new different, I've built a new different image. It's in this registry over there. Please pick it up, apply it, and make a deployment around it. The other objects that we see here are just those RBAC objects that we were talking about. We can see we create a role that says, hey, I want Cartographer to be able to list, create, etc. Deployments. We bind that to a service account, and then we apply a service account. And so we can then come and let's open up our terminal. Is this going to guess it well? There we go. So I can kubectl apply some file, and I'm going to say apply my small supply chain. It's going to apply all of those objects to my cluster. And now I'm going to kubectl get o-yaml and workload hello. And I look at my status. The first thing that I always want to check is my top line ready condition. Is it in a good state? And it says, yep, ready, true. That tells me that all of the objects that have been defined in my supply chain have been submitted to the cluster. And I can also then look at the resources, and I can get some information about each of those resources. And this tells me, hey, I'll be able to find some deployment named hello deployment on the cluster. And the same will be true for my second workload. So that just sort of shows like what are all the bits and pieces. But of course, this is just that one step supply chain, not super useful. And so I've got another supply chain, more full example, but I do want to pause for just a moment to give you an opportunity to ask any questions.
Yes, I see. I see the chat. Don't see anyone. So what I see right now, like if you have some already plain YAML that you have, you wrap that YAML inside a cluster template, and then you have a workload configuration, and then you have some variable that I see inside the reusable file, and those will that we're talking about the input and output of the next supply chain. And those
Yeah,
variable, you can go to the Kubernetes kubectl apply and check the status dot ready, and if it's successful, then you give that to the next pipeline. But if we have workload definition file, so we can make that generic, and we can just swap out the different application with it, and we don't need to change anything else. So that's the beauty of it by using the workload configuration. So tell the viewer about it, like what the part the op uses and what the part DevOps uses. Like we draw the analogy that the DevOps set up the cluster supply chain, and they tell us you can change the git, you can change the how you test the images, you can swap out with a different testing tool, but you can't swap out the scanning of the cluster, scanning the GitHub repository. It's standard. We have set up for you. You don't change that, but you can change the different other parts of it. So that is how the flexibility and how you tell us about the a different area of expertise can be achieved via this methodology.
yeah. So this gets into kind of the philosophy of Cartographer. Um, the I would say the app operator is always meant to be the empowered individual in Cartographer. So uh, the the app operator is going to define uh, a set of supply chains. That set may be a set of one, or it may be a set of you know, five, whatever you may like, and uh, the those supply chains may be similar. Those supply chains may switch between different tools based on some parameter in a workload. But ultimately, if it is on the app operator to make those choices. So if an app dev came and said, "Hey, uh, I really uh, I'm really opinionated and or even hey there's something about my code that doesn't work with this scanning tool, and so we need to use a different scanning tool, and we need to swap that in the supply chain. It's going to be incumbent upon uh, whoever has that app operator role to write a template that wraps that new tool and to write a supply chain that either hard codes that template, and then you say, hey, the supply chain is selects for workloads with this label, and you tell your app devs, hey, use this label. Or you could write a supply chain that says, hey, we do step A, B, C, and step D refers to a couple of different templates, and you can switch, and we'll switch between them based on some values in the workload. If we see value A, we'll use template one. If we see value B, we'll use template two. Uh, so in the places uh, where there's going to be choice, it's always going to be incumbent upon the app operator to make those choices possible. And I said, this gets to the philosophy of Cartographer. Part of that philosophy is um, there's there should be a decent amount of um, if an app dev came to me and said, "Hey, I want to switch step N in a supply chain," I would think of that as a bit of a code smell. Uh, I would be I really want to dig into what is it about the supply chain that's not working here? Because the goal of Cartographer is to allow you to build an app platform that protects devs from uh, needing to even know about those resources. Uh, of course, I love the DevOps model. So Cartographer is totally, you can totally be both the person that sits in the app dev role and the person that sits in the app operator role. And so you're defining both the path to production and you're defining your workloads. Um, but if you are in those separate roles and you've got a developer saying like, hey, I really care about this step in the supply chain, uh, that's definitely a time to dig in and ask, why? Um, how do we protect you? How do we uh, enable you to get out of uh, thinking about how getting your code to production and back into how do you write code that delivers value for customers?
Absolutely, absolutely. Great explanation. And I see Rashid Abdul Aziz is saying, as an operator, you can use options to provide template selection flexibilities to the dev on the chat.
Yeah,
So now, absolutely. And now, absolutely, you can go ahead and tell us the wonderful another demo of that you created, the full
yeah.
real world example.
The first thing I'd like to share is just a really quick uh, tool that I develop when I'm uh, writing uh, uh, writing supply chains. This is the Cartographer live editor. Uh, if you are looking to use this tool, you can go to cartographer.sh. It's the homepage of the project. Click on blog, and there is a blog entry for the live editor, and you can launch the editor here. So here I have, I'm going to have a resource. I'm going to give it a name, step A. Uh, it needs to have, as I said, some template ref, and it's going to have some kind. So we call it a cluster source template, and it's going to have some name. Uh, and this is pretty much what the example that I just showed had. Uh, well, now what we're going to be doing is we're going to be creating a more in-depth uh, uh, supply chain that has more steps. So I'm going to drop in a step B, and now I'm going to have a cluster image template. One might be asking, hey, Rashima, how do you choose what kind of template you're using? What's this cluster image, cluster source? And this goes back to the API that I was describing. When you are choosing a template, the template choice is based entirely on what sort of information does it need to give back to the supply chain. That hey, this object is going to be created, and its status is going to be shared back to the supply chain. There are three types of information that we expect to be used, to be passed on. One is source information. So that is a URL and a revision of source code. Uh, another is image. That is the path to some image that's in some registry. And the last is actual k8s configuration, the actual definition of some config map, some deployment, etc. Uh, and we'll see here, up here I said, okay, I've got some cluster source template. Now I'm going to say, hey, my second step, my cluster image template, it's going to be doing something like, let's make this a little less generic. It's going to be my image builder step. Uh, and I'm going to refer to step A now. And I'm going to give this just a simple name like source. If you only have one source, the name can be pretty generic. Every supply chain is built up sort of step by step, just like this. And what I'm going to do now is just grab, where is my other, go, I'm going to grab a supply chain for my more full example. Excuse me. So here we have an example of a more full supply chain. And you can find this if you look in the Cartographer repo under examples. This is the Git writer example. Here I have a source provider that is going to wrap Flex CD tool to get code into my cluster. I'm then going to use kpack to take this code and turn it into an image, push it up to a registry. You can see here a parameter that I'm passing in. What should the prefix be of each of those images that get created? Then a config provider that's going to be responsible for creating the k8s configuration that I'm 99% certain in this example, it is a Knative service. And then a Git writer. One of the things that we want to enable is users who want to build their code on one cluster and then deploy that code on another cluster. And we enable that process by allowing users, by giving examples of writing the k8s configuration that's been made to a Git cluster, to a Git repository, that then can be pulled down. So let me go ahead and switch the screen that I'm sharing. We can look at the files.
Well, the meanwhile, I learned today that the Carto has a editor. I haven't sees that previously. So I think all it does is you send out, you submit the input, and it's give you the how many steps are available in your YAML file or the Carto file.
Yeah, both the steps, and also, are they wired together properly? Are you
Yes, sir.
connecting your, connecting your, um, have you connected step B to step A properly, or do you have some, you know, some
Like where
misconfiguration
the
somewhere?
yes, absolutely. Like how the information flows, how the inputs flow between different supply chains.
Yeah. Uh, so here, I'm gonna remove the small supply chain that I applied before, and I'm actually gonna apply this full supply chain now. Um, we saw all the steps that had been defined, and I want to take a quick look at the image builder. So there's a cluster image template, uh, and we can see in here that there is reference to the workload that we had before, and now we also have these references, uh, one to that source that we described before. It said, there's going to be information that the supply chain is making available to this template. In the case that we saw earlier, we said, hey, uh, in the, actually, let me pull up the supply chain. We say, hey, this template, we will provide it with a list of some sources. And here we're not providing it with anything else. We're not giving it any other images that are available, no other configs that are available. And our image template takes advantage of the information that's been provided to it. So here we see that we've templated out this new source. And then the last thing that we notice is this param. There's some image prefix that needs to be defined for this template. Params can be defined at any of the 3 levels. Here we can see there's some default value that's being specified in the cluster image template. We've got some default value here. We also see in the supply chain that we have provided this parameter. And I'm sharp-eyed, and I've been doing this for a little while, so I noticed, hey, this is, in the supply chain, I've defined this as a value. And that's saying, I, as the app operator, I know exactly what value I want to be in there. I'm hard coding it to this this registry, this Docker registry in my project. But if I say, you know what, I'm a little indifferent as to that, and I'm fine with my app developers pushing their images to different places, then I can change this from a value to a default. And in that case, I would be able to go into my workload, and I could specify some params here. Otherwise, so those are the 2 big pieces that we see that have been added to this. What I'm going to do now is do a kubectl tree on my workload. And I'm pretty sure this one is named, yeah, getWriter.sc. And I can see all the objects that have been created. I see that first, my Git repository has been stamped out. My Git image has been created. I have a config map where my configuration has been written into it. And then I have this Cartographer idea of a runnable. Whenever I'm trying to use something like Tecton, folks that are familiar with Tecton know that you define a task, and then you define a task run. Those task runs aren't updatable. And so what Cartographer does is it provides you with this runnable object that gives you that nice update behavior so that I can update my runnable, and the runnable will be responsible for updating those task runs. And I see that all these steps are true. If I do, if I grab my workload, getWriter C, and then just get the status, I can see that my conditions we looked at before, ready, true, that's great. And I can see in my list of resources plenty of information about each step, the outputs that they are providing. I can even get a preview of what were those values that were being passed on. So I can see, hey, my source provider ran, it provided this URL to my image step. And then I can go to my image builder step, and I can see, hey, it has an output, that image output. And here I can see a preview of what's the SHA of that image that's been generated, what's the address of it. And finally, as I said, this has been pushed up to this supply chain. Its final step is to wrap a Git step that's going to push this information into some source management. And that is, remember the steps that I went through to okay, I'm no longer forwarding that. So kind of underneath the hood, what I'm doing is I'm running this. I'm running a local repository rather than pushing up to GitHub. Simplifies some things, like passwords so that I can push this up with minimal concern about exposing credentials. But then it's a little bit harder on the Git pull side. But ultimately, I would be able to go to that repository and pull down the config, which is a Kubernetes a knative service. So I'm going to stop there and ask what questions you have.
Yes, absolutely, absolutely. Great demos, great explanation. Really like the enthusiasm and passion of your taught educating people about Carto. So we have Rashid Abdulaziz is also is on the here, and he's tell us about the editor today on the Carto editor. Today it is focused on the cluster supply chain resource, and with enough interest, we may well expand it to include template editing among other things. That's great news. Great, we are working on these kind of stuff, and we saw two of these things. Like these are the final few questions from my side. I see Runnable, and Runnable I think is a CRD in Carto, and Runnable is what it does is it allow you to integrate with other toolings. Like we have already CI tooling available in the cloud native and DevOps world. By using the CRD Runnable, you can integrate those CI/CD tooling with Carto. So, is it a good way of thinking about it?
Yeah, yeah, a couple of things. One, total shout out to Rash, that's Rashid. He is a member of the Cartographer maintainers team, and the live editor that you just saw, that is his baby, and it is it's really wonderful. So big props. Uh, in terms of the uh, Oh, I was holding on to that, and now again, I've forgotten your question. Can you repeat it? Oh,
Yes,
runnable,
absolutely, absolutely. Yes, yes,
runnable.
absolutely.
Yeah. So again, there are, when we think of Kubernetes resources, we're generally always thinking about control loops, where we say, hey, I'm going to define some spec, and then the controller is going to check the state of the world and see, does this spec match, does the status of the world match the spec that's been placed there? And if not, it's going to move things closer to it, and it'll just go in that loop, 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 loop. And part of that loop for most objects is that you can update that spec, you can change the spec, and the in the control loop, they'll say, hey, this has changed. The state of the world doesn't match. I'm going to make this object come to coalesce towards its desired state. Um, and it turns out that some tooling in Kubernetes, some tooling is very popular, doesn't adhere to that. And so Tecton is the biggest one for our use case. Tecton is great for some things. And in particular, it's great for all those things that uh, haven't yet created custom resources. If you've got some tool that you want to use and it doesn't have a custom Kubernetes resource, well, you can just wrap whatever work needs to be done in a Tecton task, and uh, and then you'll be able to use it. But you'll have to figure out, how do I keep getting new task runs? You have to, after you define your task, you have to submit an object that essentially says, run that task. And then if you want to rerun it with the same values or with different values, you have to submit a new task that says, run that task, and then another run that says, run that task. Um, and that's just really different from that control loop behavior that I was describing. And so what we do in Cartographer is we say, let's template out that uh, that object, that task run, uh, and say, all the values that might change when you do, run that task one, run that task two, run that task three. Uh, those will be templated out, and you can just update the runnable object and say, hey, value A is now blah, and value A is now foo, and a task run will be created that says run that task with foo, and then you can update the runnable and say no, value a is bar, and a new task run will be generated that says run that task with bar, and it protects it provides that uh, updatable behavior, that control loop behavior that you're really familiar with in Kubernetes for resources that don't have it natively.
Yes, absolutely, absolutely. Thank you very much for explaining this. And last question, like what I see right on the screen, that is you using the Carvel language to carve out these input in the supply chain.yaml. And tell us about the Carvel in itself and what the advantages of using these annotation. It's look ugly, but it's draw the purpose.
Yeah. So Carvel is a set of tools. It's a set of open source tools that help in the Kubernetes ecosystem. Let me see if I can pull up. Screen. I'm just going to Google. Carvel.dev. So, as I said, it's a package of great small tools. And the one that you see there, that language that you're describing is YTT. It is templating overlay language that is available in Cartographer. Uh, I will say that uh, my goal when I'm writing uh, my supply chains, when I'm writing my templates, really, is I hope I don't have to use YTT. Uh, uh, Mostly for simplification. We don't want users to have to use multiple tools, to have to learn multiple tools in order to get their work done. Uh, and so YTT is there for when you have special use cases. When you have if-then logic in your supply chain, in your template, that's a time when you're going to want to reach for YTT templating. Or when you have to loop over a set of values. That's another time when you would say, whenever you are writing a template and you think, oh, I don't know how many objects in this array there are going to be. I just need to loop over a bunch of values and put those values in. Uh, that will let you know, hey, use YTT templating. Um, Otherwise, you would be using uh, that standard uh, templating from Cartographer. And so we can see really quickly, uh, maybe look at to one after the other. Here, I have my cluster config template, and I have uh, I'm defining my template in YTT rather than in template. Uh, my image template, uh, instead, we can see, hey, I've got this template field, and then I'm able to just define this object in straight YAML. If for no other reason, then hey, it's easy for uh, any YAML parser to just look at it and highlight it in ways that make sense. Uh, when you use YTT, we can see here I'm able to define some functions, uh, and my functions can utilize those functions. Uh, so here, ultimately, I'm saying, hey, create this config map, and then I want you to do some JSON encoding, some base64 encoding, and call that manifest function. That manifest function is going to call this service function that I've defined over here. YTT is great because it's like a Turing complete language. You can do quite a lot with it. Um, our our goal is to make sure that you have to reach for it as little as possible, because it's that extra bit of learning. Um, for most use cases, we expect that users will not need to use YTT, but instead they can just use those regular uh, that regular templating that has just the straightforward value uh, value replacement.
Yes, absolutely, absolutely. And when you look at the documentation, you see places where YTT is. We go to the corval.dev. It's look ugly, but it's a very powerful tooling for you to do some of the very powerful things in the cartographer. So it's been a wonderful session, Vishuma. You explain it wonderfully. You show us demos that shows the power of the cartographer, and you show us at the end some of the cool things like we talk about during the conversation whole. You do these DevOps pipeline in a separation of concern way or expertable way. Expert can know their area inside the pipeline, and also you by looking at the by the cartographer, you see it's based on the choreography pattern, and when some of the execution fail, it's still going to be run very smoothly and perform the execution at the end. So it's a wonderful explanation, wonderful demos, and you just share the GitHub repository if you have. I will share the audience later today. I might be sent out the tweet to everyone who can watch the session as well. It's been a wonderful session with you. Hope to have you again. And Rashid Abdulaziz is saying a nice demo, Washuma. Thank you very much, Rashid. And thank you very much for your awesome editor on the Corwell.dev, on the Carto editor. So you did a wonderful job there. So thank you very much. And last question, am I? What are your extracurricular activities beside Carto? Like how you spend your days, or free days, or weekends, or some free time? How do you? And also, you can add this question up. Do you go to the KubeCon?
I am going to go. I am going to KubeCon. Look out for Benoit Moussan is going to be presenting a talk there. I believe I've got that. I drop in to chat to you the event link for anyone going to KubeCon EU that wants to hear more about this tool, hear about someone that is not a maintainer, so someone who's coming to Cartographer as a user, um, how that tool empowers him. You asked, what do I do when I'm not maintaining Cartographer? There's another open source project that is near and dear to my heart. I said that I was a newish developer. I came to software engineering as a career changer. I used to be a teacher, mostly elementary school. I really, there's nothing better than being in a classroom of third grade students who are just like super pumped about learning everything about the world. Um, and uh, doing work with them and being like, hey, like I heard about this thing called Scratch. I think you guys could write some like really cool code with it. Eventually, I was like, oh, not only kids could do it, but like it's really interesting to me. And when I did, I decided that I wanted to, rather than going the boot camp route, I wanted to find something that was more affordable and also more academic. That was really focused more on computer science fundamentals and not so much hey, here's a JavaScript framework that you can learn. Like, no, go get a job in a shop doing using that JavaScript framework. Um, and I found an open source project called Open Source Society University. Uh, the website is ossu.dev. Uh, and that project is a list of uh, MOOCs, massively open online courses, free courses on the internet that you can use to approximate a undergrad degree in computer science. And so yeah, at first I was solely a consumer, and in the past few years, I've taken on more responsibilities for growing our community, as well as standardizing our curricula and growing our list of curricula. So, uh, computer science is our most liked project. Our computer science curricula is one of the top 50 starred projects in GitHub. Uh, but we have other curricula that we are developing. The one that's probably in the most active development is our math curricula. And so I always give a shout out. If you geek out on math, if you did a math degree, we would love to have your input on great resources that you've found online, or even great resources, great free textbooks that your professors may have introduced you to. Um, uh, please come to ossu.dev and give us your feedback. We also have a very active Discord channel. Over 10,000 users have registered in that channel. And so there are opportunities for mentorship. Uh, we, our most active mentors regularly reach out to me and say, hey, look at this student that's saying they landed a job because of both the curricula that we laid out for them and also the mentorship that they got to like help them over like some of those critical humps where they could have fallen off, um, because they were stuck, but instead there was a community there to keep them going.
Oh, wonderful, wonderful. Great appreciation from mine doing that wonderful work for our community. Wonderful work also done on the Carto side as well. So here is a repository that is showing all the wonderful demos that we prepare, that Vishuma is showing us today. So I will share with you later in the tweet as well. So it's been a wonderful session. Great work on the community side that you're doing both in the computer science side or the Carto side. Great work, both of them. I really enjoyed the learning view with Carto. I've spent a few of the month time with you, but today I feel like I was spurred by joining you, the core maintainer of the Carto project. I learned a lot of great detail about the Great Front project. So here's the figure for you if you want to learn about Carto. Vashuma is a figure for you to learn about all these details. And there is a KubeCon talk that he's mentioning during the. You should go and explore about it more. And if we are unable to share your question today, feel free to join us in this in the Carto Slack channel, or also DM us on in the Twitter. We're happy to have your answer covered after the session as well. Great, thank you very much, Vishuma. It's been a wonderful talking to you. I hope can enjoy the time with you again in the future as well. Pleasure to have you on my show. Thank you everyone for joining us. Stay safe, stay healthy. Bye bye everyone.